So this unit, we're talking about polygons. Polygons just means many sides. So a little more specific, a polygon is a closed figure. That means it has to connect on all sides. Formed by 3 or more line segments called sides. So each side is a line segment, like a triangle has 3 line segments. The quadrilateral, well, quad, it's the prefix for 4. There's 4 sides. Pentagon, well, that's a prefix for 5. Sorry, just like triangle is 3. By the way, you can't have a 2-sided polygon. That's an angle, okay? That's why polygons start at 3 sides. Pentagon is 5 sides. Hexagon, prefix hex for 6 sides. Heptagon is actually 8 sides. 7 sides. Sorry, octagon is 8 sides. Nonagon is 9 sides. Decagon is 10 sides. I do not expect you to be able to draw these, but I do expect that you can draw those. If you get a template, let me show you this. Well, since you're given the worksheets, I'm not going to worry about it, but there's a template, that makes drawing these easier. So a heptagon has 7 sides, octagon 8 sides, nonagon 9, decagon 10. Now, when it says number of triangles, if I draw from one vertex to another vertex in a triangle, I can't separate the triangle into more triangles. But like a quadrilateral, if I take this vertex, I can't go to the 2 vertices next to it, but I can go what we call diagonally to the opposite vertex, and when I separate the quadrilateral, I get 2 triangles. Here's the first one, here's the second one. So the number of triangles are 2 that you can split it into. This none, or we can say there's just one, the outside, that's it, okay? So in other words, when we say sum of the interior angles, all 3 angles in a triangle, we spent all of Unit 4 talking about that it adds to 180 and how we can use that information to help us in different diagrams. Well, now we're extending that. In a quadrilateral, if we add all of these 3 angles, that's 180, plus these 3 angles, that's an additional 180, or 2 times 180 is 360. Okay. Now, pentagon, you have 3 triangles. So basically it's going to be 3 times 180, which is 540. Hexagon, there are going to be 4 triangles, which is 4 times 180, which you get 720 degrees. Sorry, all of these are degrees. Is the sum of all of the interior angles. So if I took this angle plus this angle plus this angle, this one, this one, this one, it would be 720 degrees, even if they're all different. Like I could draw a wonky hexagon, and basically if I add all of these interior angles, and it says interior because it's inside the perimeter, it would equal 720. Now if you notice, there's a pattern going on. The number of triangles is always 2 less than the number of sides. So if there's, even without the diagram, we could say, oh, well, there's going to be 5 triangles. 5 times 180, well, that's going to be 900 degrees. 2 less than 8, there's going to be 6 triangles. 6 times 180 is going to be 1080 degrees. Well, 2 less than 9 is 7. 7 times 180 is 1260. And 2 less than 10 is 8. So 8 times 180 is 1440 degrees. Well, because of this pattern holds true, we have a formula. So you could have, they call it an n-gon. with n number of sides. In other words, I could have a 100th that has 100 sides, and if we subtract 2, it's going to have 98 triangles. 98 times 180 is whatever that is for the sum of the interior. So n represents the number of sides of a polygon. Then the sum of the interior angles, S, capital S, can be found using this formula. Well, S is going to equal n minus 2. Remember we said the number of triangles was 2 less than the number of sides, times 180 degrees, because there's 180 degrees per triangle. Actually, we can't put equals because you got to plug in the n. Okay, so like here, the sum is going to equal, well, 15 minus 2 times 180, or 13 times 180, which is 2,340 degrees. 48 gone, well, that's just going to be 48 minus 2 times 180. So the total sum, or S, is going to equal, what was that, 46 times 180. Oh, I moved my parentheses. It's okay. It's still just multiplication. Well, that's going to be 8,280. Okay. I'm going to have you do these in a second on your own, but let's look at some more vocab. Regular polygon. Anytime you see the word regular, you want to think everything is congruent. So in other words, we're going to say a polygon, oops, in which all the sides are congruent. And because the sides are going to be congruent, we actually, it says, okay, the measure of a single interior angle in a regular polygon can be found by dividing the sum, which is the S, when we did the number of sides minus 2 times 180, by the number of sides. So in other words, in parentheses, I'm going to tell you all the interior angles are also congruent. So here, if it says find the measure of each interior angle, well, as soon as it says regular, I know both the sides and the interior angles, INT I put for interior, are congruent. Well, pentagon, that means that you have the number of sides. So I'm going to find the total interior angle. Well, 5 minus 2 times 180. Well, 3 times 180. Oh, what did we say that was? 540. But how many interior angles? Oh, by the way, note the number of sides equals the number of interior angles. So I'm going to take that 540 and I'm basically going to just divide by 5. And so each interior angle is going to be 108 degrees. Oops. So there would be 5 angles that are 180 in the pentagon. You'll try this one on your own. Basically, you just use the n is 3 and then, or sorry, 5, oh gosh. Okay, ignore that, 18. So you do 18 minus 2 times 180, figure out the total of all the insides, but then you're gonna divide it by 18 because if there's 18 sides, there's 18 interior angles, just like a pentagon has 5 sides. So we divide it by 5 angles. Okay, so you'll work that one on your own. Now, let's talk about the sum of exterior angles. This one's interesting because, remember when we talked about the exterior angle theorem in a triangle? Well, this would be the exterior angle to this vertex of the triangle, okay? This would be another exterior angle, and this would be another exterior angle. Notice, since all 3 angles of the triangle are different, all 3 measures of the exterior angle are going to be different. And since they all form a linear pair, if we do 180 minus 61, that's going to be what, 119? let's see, a linear pair with 79, 180 minus 79, that's going to be 82 degrees. Linear pair with 40 degrees, 180 minus 40 is just 140. And then sum of the exterior angles, you're just going to add all three of these. Well, interestingly enough, it equals 360. If we did that for every single shape, just trust me, like you can do this on your own to prove it. Every single shape, it doesn't matter how many sides, all the exterior angles is going to equal 360. So if I find this, add it to this, add it to this, add it to this one, and add it to this one, it's going to equal 360. Same for each and every shape, no matter what the sides are. So what can you conclude about the sum of all the exterior angles of any polygon? I'm going to, instead of just a polygon, I'm going to put any. It's going to be 360 degrees. So what we do, what is the measure of each exterior angle of a regular hexagon? Well, guess what? Not only are all the interior angles congruent, but regular, also all the exterior angles of a regular polygon are congruent. Well, guess what? If we know the sum of the exterior angles is always 360, and it's a regular hexagon, well, if you remember, a hexagon has 6 sides, all I have to do is divide 360 by 6, and I know that every single exterior angle is 60. Well, what do I mean by exterior? Well, if I have this hexagon, pretend I'm drawing this perfect, if I extend one of the sides, this angle, x, is going to be 60 degrees, along with every single other angle. If I extend every side going in the same direction, so we don't repeat. So if I add all of these, it's going to equal 360. So we basically, because there's 6 sides, there's going to be 6 exterior angles. I divide it by 6, so it's even, and that's 60. So let me show you number 10. This one's where you're kind of working backwards. If the exterior angle of a regular polygon, now notice they didn't tell us how many sides. So we don't know what n is, because n represents the number of sides. But we know that exterior angles are going to be 40. And remember, regular means all the angles and all the sides are congruent. So what do? Well, we know the total exterior angles is 360 divided by whatever n is has to equal 40. Well, if you remember when we did proportion equations in Algebra 1, you can actually do the cross product and you get yourself the equation, well, n times 40 is 40n equals 360 times 1 is 360 divided by 40. The beautiful thing is anything divided, you could cross out the tens, which are the zeros, which means you're basically dividing by 10, and then mental math, 36 divided by 4, so n equals 9. So it's a nonagon. There's 9 sides. Okay? So pause the video, and I want you, all the problems that we didn't do, I want you to do on your own and then check the answer key that I'll post after this.